Join me as I dive into the wild world of solar flares and challenge myself to find out what really happens when they hit Earth. In this video, you'll learn about solar flares, their causes, and the potential impacts they can have on our planet. Solar flares can release an enormous amount of energy and radiation, which poses risks to our technology and infrastructure. When a massive amount of energy is released from the sun, it's like a giant wave crashing onto our planet. This wave can be powerful enough to disrupt our communication systems, navigation tools, and even our power grids. The consequences can be severe, ranging from minor disruptions to complete system failures. The radiation emitted by solar flares can also have a devastating impact on our technology. It can cause electrical systems to short-circuit, damage satellite communications, and even affect the performance of high-altitude aircraft. The risk is not limited to technology. Solar flares can also pose a threat to our health, particularly for people who work in high-radiation environments. The effects of solar flares can be widespread, reaching from the Earth's surface to the outer edges of our atmosphere. They can even impact the Earth's magnetic field, causing geomagnetic storms that can alter the planet's climate. The severity of these effects depends on the intensity of the solar flare, which can vary greatly in terms of energy release and radiation levels. The potential risks posed by solar flares are real, and it's essential that we take them seriously. By understanding the causes and consequences of these powerful events, we can develop strategies to mitigate their impact and protect our technological infrastructure. Solar flares are formed on the surface of the sun, where intense magnetic fields and electric currents build up. These fields can become twisted and tangled, leading to a massive release of energy in the form of a solar flare. The sun's surface is constantly shifting and moving, which can lead to the formation of multiple flares in a short period. The classification of solar flares is based on their intensity, with X-class flares being the most powerful. These flares can release an enormous amount of energy, equivalent to billions of nuclear bombs. On the other end of the spectrum are B-class flares, which are much weaker but still pose a risk to our technology. Throughout history, there have been several notable incidents where solar flares have affected the Earth. One of the most famous events is the Carrington event, which occurred in 1859. This massive solar flare caused widespread destruction, including fires in telegraph offices and disruptions to communication systems. In recent years, we've seen several close calls with powerful solar flares. In 2012, a massive X-class flare narrowly missed the Earth, avoiding what could have been a catastrophic disaster. These close calls serve as a reminder of the importance of monitoring solar activity and being prepared for the worst-case scenario. One of the most significant solar flare events in recent history is the Halloween storms of 2003. This series of powerful flares caused widespread disruptions to communication systems, navigation tools, and even the power grid. The storms were so powerful that they overloaded the Earth's magnetic field, causing spectacular aurora displays to appear at lower latitudes. The most significant consequence of the Halloween storms was the power outage that affected millions of people. The outage was caused by a geomagnetic storm that induced electrical currents in the power grid, leading to a cascading failure of the system. The event highlighted the vulnerability of our power infrastructure to solar flares and the need for better preparedness. Solar flares can have a profound impact on our daily lives, from disrupting communication systems to causing power outages. By understanding the risks and consequences of these events, we can take steps to mitigate their impact and protect our technological infrastructure. To wrap up, we've seen how solar flares can dramatically impact our daily lives and the importance of monitoring solar activity. It's essential that we take the risks posed by solar flares seriously and work towards developing strategies to protect our technology and infrastructure. If you found this video interesting, check out our related video on how to protect your technology from solar storms, and leave your thoughts in the comments below.